Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This is a sequence involving oxime formation, Beckmann rearrangement, and LAH reduction. Moving on to the next step. Cyclopentanone reacts with hydroxylamine, NH2O, to give cyclopentanone oxime, A. The C is equal to O is converted to C is equal to NO. Moving on to the next step. Treatment of cyclopentanone oxime with H+, acid catalyst, causes a Beckmann rearrangement. In a Beckmann rearrangement, the oxime of a cyclic ketone undergoes ring expansion to give a lactam. Cyclopentanone oxime, 5-membered ring oxime, rearranges to give a 6-membered lactam, specifically delta-valorolactam, to piperidinone, which is compound B. And for the final step, LAH, lithium aluminium hydride, is a strong reducing agent that reduces amides lactams to amines. Reduction of 2-piperidinone, a cyclic lactam, 6-membered ring, with LAH reduces the C is equal to O of the amide to CH2, giving piperidine, fully saturated 6-membered ring with 1 NH. This is compound C, option A, 4-hydroxypiperidine. No source of O at C4 LAH would not introduce a hydroxyl group in this position from a lactam. Option C, 2-piperidinone. This is intermediate B, not the final product C after LAH reduction. Option D, 3-hydroxypiperidine. No mechanism accounts for O at C3 in this sequence. Option B, piperidine is the correct product because LAH fully reduces the lactam, 2-piperidinone, to piperidine. Therefore, the correct answer is B. Therefore, the correct answer is option B.